This conference will now be recorded.
Good evening, all. Good evening, all. I will be presenting a demo session on DFT. So, DFT, it basically stands for this 1 minute. DFT basically stands for Design for Testability. Design for Testability. So, what basically happens in DFT, we will be inserting some test structures into the design. So, we will be like inserting some test structures into the design. So this test structures, it will be inserted during the pre-silicon stage, pre-silicon manufacturing stage. We will be inserting some test structures in our design. So these test structures is used to detect the manufacturing defects in the chip. That is the defects which occur after the manufacture. That is post-silicon manufacture. If there are some defects, then our circuit, our additional test structures which we have added during the pre-silicon stage will be used to detect the manufacturing defects after the production of silicon. So this is what is DFT. So DFT stands for Design for Testability. So DFT is to add some test structures into the design, and it will be added during the pre-silicon stage. So that is used to detect the manufacturing defects in the chip. So basically what a DFT engineer does is, as I said, DFT is to add some test structures into the design. So those additional test structures, the adding of those additional test structures will be done by the DFT engineers. And why we are actually adding these additional test structures? In order to test our chip properly, in order to detect any manufacturing defects, in order to detect any manufacturing defects, we will be adding these additional test structures. So in order to make sure that our testing is done properly, we will be adding these test structures. And DFT engineers, they do not check the functionality. we check the quality of the chip. So quality of the chip means whether the chip is bug free or not. Whether the chip is bug free or not. So this we will be checking whether there are any manufacturing defects in the chip or not. We are not going to check the functionality of the chip. The functionality of the chip will be checked by the functional verification engineer. DFT engineers, we will be checking only the quality of the chip. That is, we will be trying to check whether there are any manufacturing defects or not, and if there are any manufacturing defects, we will try to detect the manufacturing defects by adding some extra logic into our design during the pre-silicon stage itself. So we'll see what are all the prerequisites of this course. First thing is like digital design basics. So like combinational logic and sequential logic, and then basic electronics like basics of CMOS is required. Then any one of the hardware description language, either Verilog or System Verilog or VHDL. So we will be using Verilog. So very basics like the structure of Verilog. So how to declare the ports, how to declare wires, so and how to change the connections. So very basic, the structure of Verilog, basic combinational and sequential logic design, how it is done. That basic idea is required. And understanding of VLSI design flow, so that I will be discussing in the next few slides. Next is basics of EDA tools. So EDA tools, we will be dealing with this in our labs. So EDA is, the full form of EDA is electronic design automation. Electronic design automation. So we will be dealing with uh, these EDA tools in our lab session. So what basically these EDA tools does is, like EDA tools, they are capable of doing tasks on their own. But what task it has to perform? So that we will be giving the instructions. So through some commands, we will be telling the EDA tool what it has to do, so that the EDA tool will be doing those tasks. So say for example, if we want to insert a particular logic, so the EDA tool will insert the logic on its own. So what logic it has to insert, how it has to insert. So those things we will be telling it to the EDA tool with the help of some commands. And next is basic knowledge of C, so that I'll tell you why it is required. And next is the scripting languages. So scripting languages, any one is required, Perl, Shell or Pickle. So in our institute, we will be taking Pickle sessions. So Pickle, why these scripting languages are required is, as I told in EDA tool, they will be able to perform tasks on their own, but we have to give the instructions to the tool to tell what task it has to perform. So that instruction, what the tool has to do, that instruction we will be, in order to communicate it with the EDA tool, we will be making use of the scripting languages. So we will be making use of Pickle scripting languages. Perl and Shell are also like similar to Pickle scripting. And the structure of Perl, Shell or Pickle is similar to C program structure. So if you know C program, then you can easily learn any one of the scripting languages. And next is we'll see who can attend this course. So if you are a final year student and if you want to like, if you're having a DFT as a final year subject, or if you are like want to get into like VLSI domain after your college, then you can attend this course. And a new college graduate who is from relevant branches of engineering, so you can also attend this course. And lecturers or professors who want to shift to industry can attend this course. And working professionals, so if you want to change your domain, you can also attend this course. So now we can see some basics of VLSI. So VLSI stands for Very Large Scale Integration. VLSI stands for Very Large Scale Integration. Very Large Scale Integration. So what you see in this diagram in the left and the right side is actually a chip. So what basically VLSI means is implementation of millions of switches in a small area. So Small area is nothing but our IC. IC stands for integrated circuit. Integrated circuit. And millions of switches is nothing but our MOSFET. Millions of switches is MOSFET. So implementing millions of MOSFET in a small area, in a small integrated chip, that is what is called as VLSI. So this is what is a chip which you are seeing in the right side. So motive of VLSI is nothing but if someone is designing the chip, so they will be having some primary conditions that has to be met. So the first thing is high performance. Performance means how fast our chip responds. So how fast our chip responds. So yeah, so that is what is called as high performance. So we should have a high performance. Our chip must respond quickly. And next is low power. So why we require low power is, if suppose our power is high, then it will damage our chip. So that's why we must try to have low power. And then low area. So if we have a large area, then it will actually increase our board size. So if it increases our board size, it will in turn increase our product size. So if we want our product size to be small, then we must have a low area. So these are the main goals while designing a particular chip. So these are the main targets or main conditions which has to be met in order for a chip to be designed, in order to design a good chip. So next we will see the ASIC flow. ASIC stands for Application Specific Integrated Circuit. So application specific means specific to a particular application. So say for example, if you have developed a chip for medical industry, you cannot use that chip for automobile industry. So it is like application specific. So applications are by the medical industry and it is specific to that particular industry. It is specific to that particular application. So that is what is called as application specific integrated circuit. So ASIC flow, it basically gives you the steps which a chip has to follow while designing the chip. So which we need to follow while designing the chip. So steps for designing the chip will be given in this ASIC flow. So the first step is like design specification. So based on the application for which we are designing the chip, the design specification will be decided. So it will be actually decided by very experienced people in the domain, around 20 to 25 years of experience. They will be called as architects. They will be defining the design specification. So based on for which application we are designing the chip, based on that they will be deciding the specification. Next comes the design code stage. So that is the based on this application, based on the specification, the Verilog or VHDL code will be developed by the design team. So that and this code it will be in RTL format. So RTL means it will be like register transfer level. That is, data will be transferred between registers. So RTL code, that is, it will either be behavioral code or else data flow level code. So either a behavioral model code or data flow level model code will be developed by the design team. So the Verilog code, that is the RTL code for the circuit for the chip, will be developed by the design team. Then we have the verification team. So in order to check whether the design, which is whether the RTL code which is developed by the design team, whether it is working properly or not, whether it is functioning properly or not, will be checked by the verification team. So they will be having some methodologies with which they will be validating whether the design code is working fine or not. Next we have the synthesis stage. So synthesis stage, what basically happens is we will be converting that RTL code, the RTL code which was developed by the design team, it will actually be converted into gate level netlist. Gate level netlist. So this is actually done by the synthesis team. And this gate level netlist, it will be technology node specific. Technology node specific. So for example, like 28 nanometer technology node, like that. So it will be technology node specific. The RTL code, which was developed by the design team, will be converted into gate level netlist, that is in the process of synthesis. Okay, so this will be done by the synthesis team. And after synthesis, we have our DFT team. So design for testing team. So as I told earlier, DFT team, we will be adding some structures into the design during the pre-silicon stage itself, so that if there are some manufacturing defects, our logic will be able to detect those manufacturing defects. So there will be a question whether we can do the testing without DFT team or not. So the answer is yes, we can do testing of the chip without DFT team also. But then why do we have this team separately? Why do we have DFT team separately? Because without DFT team, the test time will be more. So without DFT, test time is more. So with the DFT, test time to test time will be reduced. So how test time is reduced is because DFT team will be giving optimized set of patterns. Optimized set of patterns. So after the manufacturing of chip, it will actually be tested on a tester. So to that tester, we will be delivering an optimized set of patterns. So with that, we will be able to reduce the test time. So without DFT team, if we are able to test the chip in 2 days, then with the DFT team, we will be able to test the chip in less than 2 seconds. So how we are able to do it is with the help of the optimized set of patterns. So we will be to the tester, we will be delivering a set of patterns which will be optimized. So if we apply those patterns if we apply those patterns onto the chip, then our chip can be tested in less than 2 seconds. So why test time is basically important? Why we have to see our test time has to be reduced. So after manufacturing, after the manufacturing of the chip, that is post silicon manufacture, we will actually be checking the silicon onto a tester. So we will be having a tester here. So the chip will be placed onto the tester. Some input patterns will be given, and the output patterns will be output responses will be there, and that will be actually compared with a golden response. So this will be done after manufacture. So after manufacture, there is a step called as testing. Okay, so during this testing time, the chip will be placed onto a tester, and some input values will be given, and the output responses will be getting, and that output response, it will be compared with the golden response or the expected response. So this tester, it is actually very costly. So all the companies cannot afford this tester. So one company will be having this tester, and that company will be renting out the tester. So say for example, company A is owning a tester. So he will be renting out this tester to other companies. So even the rent, it is actually very costly. It will be in dollars per second. So that is why we have to make sure that our test time is reduced. Okay, so after manufacture, we will be placing the chip onto a tester. So that tester, it is actually very costly, and even the rent of the tester is also very costly. It is in dollars per second. So that is why we have to make sure that our test time should be reduced. So in order to reduce our test time, we will be going for this DFT team. So DFT team, how we are able to reduce the test time is with the help of optimized set of patterns. We will be able to develop optimized set of patterns. So because of that, our chip testing can be done in less than 2 seconds. So that's why we are actually going for, that's why we are having a separate team called as DFT team. Next comes the physical design team. So the physical design team, they are responsible for the layout of the circuit. They are responsible for layout of digital circuit. Next comes the sign-off team. So sign-off team, they will actually be taking care of 3 tasks. One is STA, next is physical verification, next is logical equivalence check, LEC, logical equivalence check. So SPA is, they will check whether the timing is met properly or not. Physical verification, they will check whether the layout of the circuit which is done by the PD team, whether that is done properly or not. And logical equivalence check, they will check whether the RTL code and the gate level format, whether it is equivalent or not. So that is what will be done by the sign off team. And next is the tape out. So all these things, whichever I told, like design specification, then design code, verification, synthesis, DFT, physical verification, sign off, all these things are actually, all these steps were also a team actually. So each step will be done by a separate team. But the tape out, it is not a team, it is just a phase in this ASIC flow. So during this tape out, we will be delivering the database to the manufacturing unit. So this phase is only called as a tape out phase. It is not a separate phase. It is just a phase in the ASIC flow. We will be delivering the database to the manufacturing unit. And next is packaging and testing. So during this testing, this post-silicon testing only, we will be placing this chip onto a tester and we'll be applying the patterns and we'll be getting the outputs. So this tester is only very costly and even the rent is very costly. So we cannot afford a lot of cost on testing. So that's why we have kept a separate team called as DFT team so that our test time will be reduced. So this is the ASIC flow. So next we will see what is actually testing. So testing is a process of determining whether a device is good or not, whether it has any manufacturing defects or not. So what basically happens during testing is, so first thing is test pattern generation. So this test pattern generation, that will be generated by the DFT team in a process called as ATPG, automatic test pattern generation. And then, so this test pattern, so these test patterns, it will be delivered to the tester team. So this test pattern actually contains the input sequence and the expected response. That is the good machine response. It will be contained expected response. So this will be given by the tester team. So this test pattern is generated by the DFT team and it will be given to the tester. So tester, what they will do, they will apply the patterns. So they will apply the input patterns. So this is nothing but a tester. So on which we will be having our chip. So this is nothing but our tester. Okay. So on which we will be having our chip and we will be getting the output. So this output, it will be compared with the expected output. So that's why I have given this diagram line actually. So the output from the tester will be compared with the good machine output, that is the expected response. So if a particular chip fails on the tester, the testing engineer, they cannot analyze it. DFT engineers will only be analyzing it why the chip has failed. So how we are able to analyze it? With the help of the test structures which we had inserted during the pre-silicon stage. Okay, so this is what happens during testing. So after manufacturing, our chip will be placed onto the tester. So a pattern will be delivered by the DFT team, so to the tester team. The tester team will be applying the patterns onto the chip and they will be getting the output, and that output will be compared with the good machine output. So if suppose if this chip fails, then the tester team will not be able to analyze it. They will be like a DFT team only will be analyzing why the chip has failed, what has caused the chip to fail, what is the manufacturing defect, because with the help of the test structures which we have already inserted during our pre-silicon stage. And next we will see what is the flow of DFT. So first is insertion. Insertion is like adding the extra logic. So what we will be doing is we will be doing a phase called as scan insertion, same way EDT insertion, and next is MBIST insertion. So all these things are like adding the extra logic. We will be adding some extra logic in the pre-silicon stage, right? So those extra logic will be added during this insertion stage. So next is pattern generation. So this will be done during the ATPG stage. During the ATPG stage, we will be generating the pattern. And finally, simulation. Simulation is nothing but validating the patterns of ATPG. Validating the patterns, validating the patterns generated during ATPG. So this is the flow of DFT. First is insertion, that is we'll be adding the extra logic into our design. Then we will be generating the patterns in the stage called as ATPG. Then finally we are having the simulation, that is we will be validating the patterns which were generated during ATPG. And now we will see the course architecture, course outline. The first thing is the DFT architecture. So we will tell you in brief. So what is the DFT architecture? How a DFT logic is used to test the test the design. So all those things will be dealt in the DFT architecture stage. Overview of DFT will be given in the DFT architectures class. Next, we have the scan insertion. So scan insertion, it is like to uh, test the combo logic and sequential logic. In order to check the combo logic and in order to test the combo logic and sequential logic, we will be going for scan insertion. And next is compression. So compression, so it is actually like so it is used to reduce the test time only. So compression stage, it is used to reduce the test time only. So just for an example, I'm telling, without DFT, if we were able to test the chip in X unit of time, then with the DFT, we will be able to test the chip. We will be able to reduce the test time by some 10,000 units. Okay, 10,000 times we will be able to reduce the test time. Now with the DFT plus compression, if we go, we will be able to reduce the test time by 1 lakh times. Okay, so that is why compression is to reduce the test time even further. We will be going for compression. And next is the on-chip clock controller, OCC. So why it is required? We will be like dealing it in detail. So during our course. And next is ATPG, that is to generate the patterns. And next is simulation to validate the patterns which are generated during ATPG. Next is MBIST. So scan insertion, through scan insertion and ATPG, we will be able to test the combo logic and sequential logic. Now for MBIST, for memories, you need a separate circuit called as MBIST. So MBIST stands for memory built-in self-test. And next is JTAG. So JTAG is actually a standard protocol. It is a IEEE standard. It stands for joint test action or access group. So some people tell it as action, some people tell it as access. So joint test action or access group. So this is the IEEE standard. So JTAG will actually be used to reduce the number of pins which are required for DFT. So how it will actually reduce it, we will see in our course. And next is boundary scan. So boundary scan, why it is required is, so say for example, this is one chip, this is chip 1, and this is chip 2. This is chip 1 and this is chip 2. So chip 1 and chip 2, they would have got separately tested by various testing schemes which we have discussed above. Okay, manufacturing, if there are any manufacturing defects in these two chips separately, then those manufacturing defects will get detected with the above steps. So there will be some interconnection between the two chips. There will be some interconnection between the two chips. So in order to test the interconnects between the two chips, we are going for boundary scan. We will be going for boundary scan. Just a minute. 1 minute. Okay. So in order to test the interconnection between the chips, we will be going for boundary scan. And next we will see what are all the tools which are required for DFT. So these are all the tools which are used for DFT in the industries. So we will be mainly using the Mentor graphics tool. So we will be using for MBIST, we will be using Tessent MBIST, and for scan insertion we will be using Tessent DFT Advisor, which is also called as Tessent Scan. Then for scan compression we will be using Tessent Test Compress. For ATPG test pattern generation, uh, sorry, yeah. For ATPG test pattern generation, there are two tools provided. So FastScan and Test Compress, we are having both the tools. And then we will be like for ATPG, we will be sorry. So for simulation, we will be going for Questa Simulator. So for all the steps, we will be using Mentor Graphics tool. So only for synthesis, we will be using DC Compiler, which is a Synopsys tool. So these are all the tools which are actually used in the industries. So in our institute, we will be using Mentor Graphics tool for all stages, except for synthesis, we will be using Synopsys tool. And next is the labs. So we will be having MBIS labs, JTAG labs, that is IJTAG. IJTAG is nothing but internal JTAG. So MBIS insertion, JTAG insertion, and then we will be having scan insertion. So there are two approaches. One is top-down approach, and the other one is bottom-up approach, which is also called as hierarchical scan. So for both the things, we are having test cases. Then we will be having EDT and OCC insertion. EDT is nothing but compression. So that is what is EDT. In Mentor tool, it is called as EDT. Compression stage in Mentor tool, it is called as EDT. So EDT and OCC insertion, then ATPG, then ATPG simulation and MBIS simulations, and that's it. So these are the course outlines which we are having. So these are the labs which we'll be seeing. And the types of companies, there are basically two types of companies. One is the product based companies and the other one is the service based companies. So product based companies means they will be like building their own, they will be building their own chips and they will be selling it to their vendors. Service based companies means they will be working for product based companies. They will be uh, uh, they will be building the chip for service based companies. So for example, if you see like Prenustech, if you see, it is a service based company. So Prenustech, it will be like a Prenustech will be working for say for example microchip. So they will be building the chip for microchip. But microchip, it is a product based company. So product based company, they will be like building their own chip. So this is the difference between the product based company and service based company. So there are two types of companies, product based and service based. Product based, they will be building their own chip. Service based, they will be building the chip for the product based companies. And what placement support will be available is we will be having tie-up with various VLSI companies. So we will be conducting various assignments, we'll be giving various assignments, tests, and some mock interview sessions will be there. So based on your performance in these tests and test series, we will be supporting you for placement. We'll be giving you placement support. But it doesn't mean that if you don't perform well in these, if you don't perform well in the test or assignment, if you are not able to perform well, it is not that we will not be allowing placement support. We will give you additional support so that you will be able to apply for the placements, and everybody will be given a chance to apply for placements. Okay. And next is mock interviews will be conducted where previous batches questions and all will be discussed with you. And same thing, previous batches question paper, interview questions, and those previous batches interview questions will be given as a practice session for you during the mock interview session itself. And that's it. Thank you. So if you have any doubts, you can ask. Lab sessions, new topics will be taken during the weekends. So weekends, new topic will be taken, and during the weekdays, whatever was taught during the weekend, that will be done as a practice session. New topics will be covered in the weekend. During the weekdays, it will be a practice session of what was covered during the weekend. Prithvi, like this question, I'm not sure. So I will ask so either admin sir or someone to join the session. They will clear your doubt. Okay, just a minute. I will call them to join this meeting. Okay, sir is not picking up my call. So what I'll do is I just a minute, sir is coming. 1 minute. Okay, sir said sir will be joining the session. Uh, lab sessions I will be taking. Theory sessions will be conducted by another teacher, another sir.
Hello. Hello. Am I audible to everyone?
Yes, sir, you're audible, sir.
Yeah, so good evening everyone. I am Vaibhav, manager of VLSIGuru. So I hope all the technical things and how the course will go is clear from Disha. Any queries regarding how the course, the curriculum will proceed, what are the timings, what are the placement support? Okay, one question that I got is what is the difference between classroom course and weekend course? Basically, a classroom course is we can say as a full course also as well as weekend course also. Classroom training is nothing but offline, where the candidate is available at Bangalore premises and he is attending the sessions face to face. Where weekends also he can come to the institute and attend. That is called as classroom or also called as offline training. Whereas in online you can attend the same sessions but from your remote location and you can do the training in online also. Sorry, on weekends also. Every session recording will be provided to you. You have to go through the recordings. Basically, for the weekend batch, for weekdays preparation, that is Monday to Friday, a recorded videos will be provided, and Saturday, Sunday, there will be doubt clarification sessions for initial 2 months. Once the project starts, dedicated weekend batch will also be running, where 9:30 to 1:30 there will be a theory, and 2 to 6 or 2:30 to 6:30 will be a lab. Yeah. Any more questions? Prithvi, Rishita, Prashanti.
Hello.
Yes, Prithvi, please tell me.
Yeah, current.
Yeah, Karan,
I'm
please tell me.
already a working professional in D. Like there will not be any need for placement for me. So I want to discuss on that, please.
Sure, sure. See, what I will do is, I think all of you have the institute number which is uploaded to the website. Right now, I will share the number in the chat box. So this is my contact number. Any discussion requirement like only projects or basics plus projects without tool access or anything is there, you can directly reach out to me via call or WhatsApp. We will discuss individually and clear all the queries.
Okay. Okay. Fine. Thank you.
Yeah. See, what happens is it is better to clarify all the queries before starting of the course. If you have any queries, it's not like only starting of the course. Meanwhile, also if you come across any questions, you are open to come and ask the doubts. But since it's a demo session, you have got all the technical clarities. Along with that, if there is anything, do let me know. Parth, Rishita, Shravan. Okay, so see, we will be starting a batch from this Wednesday. Okay, so we are given a time for enrollment till Tuesday, and from Wednesday itself, we will add all the enrolled candidates into the group and we will start the training. It will be starting from the scratch, like digital design, Verilog basics, then DFT basics will start. Okay. For any queries or anything, you can contact me on the number I've shared. So I think there is no questions from the candidates. We can end the meeting or here. Still, you can reach out. So thank you, Vidisha.
Thank
Thank you
you,
all
sir.
for attending the meeting.
Thank you all. I'm winding up today's demo session.